Managing resources. If I were to think of one word that serves as the key frame or keystone for this nugget, it would be the idea of the workload. We know about the automatic workload repository. We know how to use SQL tuning tools in Oracle where we create a workload and analyze it. In this nugget, we look at workloads from a slightly different perspective. We're looking at more of a hardware perspective here. In other words, you obviously have different groups of sessions coming into Oracle, right? Your end users who may be more interested in transaction processing. At the same time, you probably have some reporting folks in there who are doing analysis. At the same time, still, you might have maintenance jobs and batch and extract, transform, load jobs going on. Maybe the application itself wants to get into the database. This constitutes what's called a mixed workload. And the idea here is, how can we guarantee quality of service for some sessions? How can we make sure, for instance, that our batch jobs or our maintenance task jobs don't consume too much CPU and close out our users? On the other hand, how do we prevent certain user populations from consuming too much time on the server, too much CPU, etc.? Well, the answer to that is a technology that's been around in Oracle for a while, so it's fairly mature. It's called the Database Resource Manager, also called just the Resource Manager. And as we're going to learn in this nugget, we're going to learn what it is, why it's useful, and then how to actually use it. We'll create the various Resource Manager components, and by the end of this nugget, you'll certainly be able to answer successfully any questions about Resource Manager that you'll see on your OCP certification exam. Let's get started. So as I said, Database Resource Manager addresses these problems. First of all, the notion of the mixed workload. The fact that the host operating system, regardless of whether you're running Oracle on Windows, Linux, or Mac OS X, the OS has no knowledge of Oracle's priorities. The operating system can schedule processes all day long, but the problem with that is Oracle itself is one of those processes. And then, of course, you have your instance sub-processes like the manageability monitor and checkpoint process, etc. But we can't get down to the granular workload aspect at the operating system level. So that's specifically where Resource Manager comes in to fill the gap. It's a QoS, or quality of service tool, in which we can guarantee session parameters. CPU is just one of many parameters that we can schedule through the Resource Manager, but we can guarantee sessions a certain level of service and prioritize them thusly. Now, that guarantee, I said, it goes to user groups. That's not the whole picture. Specifically, and we'll see this in Technicolor in the demo, we provide quality of service to Oracle sessions. In a sense, Oracle doesn't care whether that session represents an Oracle user, a process, an application. It has no care about that, but you'll see that it's crucial for us as administrators to take those different sessions into account. We're actually going to form what are called consumer groups out of those different session types, and then the consumer groups get plugged into a resource plan. I'm getting a little bit ahead of myself though. As I said, CPU is just one thing that can be scheduled, and it's an important aspect of hardware, no question about it. As I said, you may want to make sure that at least during specified times, sys processes always run at a higher priority or have more CPU access than anybody else who may be hitting the server. And I mentioned the term Windows. We haven't formally specified maintenance windows yet. We haven't formally explained them, We'll do that in the next nugget when we discuss the scheduler formally. But what's especially flexible about Resource Manager is that we can create a plan that's really granular, that cuts up CPU among these different consumer groups, and then we can attach the schedule, or we could create multiple schedules, actually, multiple plans, I should say, and plug those into different windows, scheduler windows on our system, so that maybe during the day, plan A is in effect that has a certain weighting of CPU and other resources to different groups, and then at night we automatically switch to a night plan that has a different set of processor priorities. Isn't that awesome? Now look at some of the other aspects that we can schedule or customize in our resource plans. The degree of parallelism, and this of course refers to Oracle's parallel execution of SQL statements. Increasing the degree of parallelism for a session is going to give that session much more processing power, of course. Undue pool size. We can stretch or contract the amount of disk space a session can create and undo. Concurrent active sessions, you wind up giving a consumer group a session pool, basically. Maybe if we set this to 5 for our daytime staff, the 6th session that comes along is going to be put in essentially a waiting area or an on-hold area, and once somebody or another process logs off and opens up a slot, this waiting user can come in. Execution and idle time limits. After a certain amount of idle time, you're disconnected. Execution time means that processes that hold resources and therefore hold locks and latches for X number of seconds or minutes will get terminated unless they're able to finish within that time limit. Actually, if you studied the DBA 1 Oracle skill set, a lot of this resource manager stuff, these parameters that we can schedule and prioritize, are similar to the notion of user profiles where we can customize an Oracle user's environment. This works very much the same way, but of course the purpose here is fundamentally different. Here we want to guarantee quality of service for specific session populations in Oracle. Now let's get to the really important stuff for your exam success. It's absolutely crucial that you be able to differentiate among these resource management components. I've already kind of slipped in some of the terminology just to get you initially familiar with it. A resource consumer group, or for short, consumer group, is a user or a session. As you'll see, consumer groups can actually be mapped to more than just Oracle users. You can plug in application names, service names, host names, computer host names. It's very rich and robust in terms of how you define a session. But the bottom line with the resource consumer group, it's a logical entity that contains mapped sessions that share similar resource requirements. Now, how you group your sessions is completely up to your workload. I gave the example of daytime and nighttime processing. Maybe you want to favor OLTP during business hours and you want to favor OLAP and maintenance tasks at night. To wit, you'll want to group sessions who are doing OLTP stuff into one consumer group. OLAP might be a second consumer group. Maintenance tasks might be a third. You can encompass as many of these groups as you want. I would suggest that you keep it as simple as you can while being as granular as you need to be to cover all of your workloads. Now, a resource plan represents a blueprint for resource allocation. In this schema, you would have one resource plan for day use and another resource plan for night use. What can become kind of complicated is the fact that Oracle can have only one plan active at once. Now, in this case, day and night, that's pretty easy. But what if you had subsets on your day group? Maybe you had some OLTPers, but you also had some batch jobbers. You see what I'm saying? And you wanted to further partition resources among those subgroups. As it happens, you can create subplans. So you would have a top-level plan that divides CPU, parallelism, and the like, not among consumer groups, but among subplans, which themselves partition those resources on the basis of consumer groups. So that's how we get around the notion that Oracle can have only one resource manager plan active at once, and we can in fact embrace multi-level, more complicated schemas. Now within each resource plan, the actual rules are called resource plan directives. So if I were to draw this schematically, we would have a resource plan that consists of one or more directives or rules, and each of those rules is going to specify a consumer group. If you've worked with firewall configuration, VPN configuration, you're used to the notion of rules, and it works very similarly here. You want to create rules that are granular. For instance, maybe you want to always reserve a certain amount of CPU for the sys users, and then any leftover resources go to a second level of priority where you can divide them among two or more or just one consumer group. You can actually go out 8 levels of priority if you want to. Again, I would suggest, though, that you try to be as simple and straightforward as you can with your plans. Before we head out to the demo, I want to show you some extracts from the Oracle documentation. I provide the reference down below so you can check out the context at your leisure. This whiteboard shows a simple sample resource plan from the Oracle docs, and it mirrors what I've been talking about in passing, having, say, a daytime plan and a nighttime plan. This one just shows a daytime resource plan that consists of 3 directives, and again, this is really simple. We're just concentrating on CPU utilization here, such that we're devoting 75% of the CPU to the consumer group OLTP, 15% of the CPU to reporting, and 10% to other groups. So it looks like the OLTP sessions are always, when the server is CPU starved, going to favor the OLTP, and reporting will always have favor CPU-wise over other groups. Now this other groups is pretty important. There's actually several pre-configured consumer groups. OLTP and reporting would have been created by the DBA. They're not in box, but there are at least 2 consumer groups that you need to remember for the exam. Other groups is one, and the other is called sys group. Now the sys group, built-in consumer group, automatically is mapped to all sessions created by the sys or system accounts. If we wanted to create a directive that customized access for the administrators, we would invoke the sys group built-in consumer group for that directive. By contrast, a resource plan always has to have a directive that's mapped or associated with the built-in other group. Now, those of you who have done VPN and remote access and firewall configuration and have done rules along those lines know that you always need to have a catch-all. I always think of rule sets as a filter basket. You get all of these incoming connections coming in, and your rules are basically nets within that filter basket. The first net might catch some users or some sessions. The second net might catch some more. Eventually, you're going to come up against sessions that aren't affected by any of your other rules. So you don't want them to slip out of the filter basket into your coffee. It's going to taste bad. Instead, you want to always have a default rule at the end that catches anybody who hasn't been picked up by a previous directive. This is where other groups fits in. It applies to all sessions that belong to a consumer group that's not part of the active plan, and just like I said, is not affected by any of your other directives. I also want to make a comment based on this picture that these percentages only go into effect when the CPU utilization becomes in question. In other words, when it's 100%, when Oracle is in fact coming up against CPU contention, then it will start provisioning according to these percentages. These don't represent caps or maximum CPU, they represent minimum CPUs, all right? That's an important distinction. So in the event of CPU being pegged, we can guarantee in Directive 1 that OLTP will have at least 75% access to the CPU, reporting will have at least 15, other groups 10. Now, if OLTP are not doing anything, maybe those folks are out to lunch, and the reporting people aren't doing anything in Oracle at the moment, it's possible that other groups could have 100% of the CPU. It's always a case of spillover and just guaranteeing a particular CPU minimum. Now, as we're going to see in the demo, some of the other provisions that we can add to directives are more cut and dried. The degree of parallelism, for instance, is just an integer value. The maximum of concurrent sessions. CPU is a little bit more fluid in terms of how it's provisioned. Also, you might be thinking to yourself, what if a user belongs to more than one consumer group? In other words, what if we had Joe user or Jane user or an application process, some session that was associated or mapped to both OLTP and reporting? How would we know which one should go into effect? Which one takes priority? Well, there's 2 things we can do there. As I mentioned, you have up to 8 levels of priority, such that we can specify OLTP as being a higher priority consumer group and higher priority directive than the one for reporting, such that if the session were in both groups, they would be associated with OLTP. That's one way. The other way is called consumer group switching. We as an administrator can take a session out of one group and switch it to another, such that in this case, if we had OLTP prioritized above reporting's directive, but this particular session we wanted to make sure was in reporting, we can make that switch happen. That's no problem. I also want to show you the out-of-the-box resource plans. The thing that I really admire about Oracle is that they take something that's very complicated, like Resource Manager is very complicated and consists of many moving parts. They make it as easy as possible for us DBAs and Oracle application developers to get off the ground. In other words, they've given us a bunch of out-of-the-box stuff to start with. I mentioned two of the built-in consumer groups, sys group and other groups. Here we're looking at pre-built resource plans, and you'll see that they cover really a lot of the standard bases that most businesses have on their plates who are using Oracle in an enterprise framework. The default plan is a general purpose plan that prioritizes sys. That's all this is. So you could just simply activate this plan out of the box blind to guarantee that sys accounts, that administrators will have more privilege on the system than anybody else. Default maintenance plan, another pre-done, canned, out-of-the-box plan that's associated with maintenance windows that caps CPU resources for your maintenance tasks. We're going to revisit this in the next nugget when we deal with the scheduler. It's always a concern for many DBAs that they feel a little nervous about instituting automatic maintenance tasks because there's a thought, well, I can't control how much CPU they're using, and I'm afraid that even if I run these jobs at night, they might interfere with some other things I have going on the server. Well, something like the default maintenance plan, which we can customize. You can always come in and tweak up these pre-configured resource plans. They're not carved in stone. But here we can rest assured that when the default maintenance plan is active, we're preserving CPU for those tasks. Mixed workload is a general purpose resource plan. DSS you might recall stands for Decision Support System, extract, transform, and load, batch, and then we have one that prioritizes ETL over DSS. These are basically opposites of each other. And as you'll see in our upcoming demo, we're going to drill in and take a look at the rules or directives behind each of these pre-configured plans, because quite honestly, friends, you may just want to stay with these out-of-box plans, maybe tweak them up a little bit to suit your needs, but you don't necessarily have to start from scratch and build a plan from the ground up. I just want that to be crystal clear to you. Finally, I wanted to show this table. This is an important table from the Oracle documentation that shows the group mapping rules. Remember, I mentioned that the consumer group is a logical entity that's meant to aggregate sessions with similar resource needs. Now, how do you populate those groups? As a systems administrator, you know, for instance, in Windows, we could create, say, a global group, a domain global group, and populate it with user accounts. Simple as that. Kind of the same idea here, only it gets a little bit more abstract because we have the notion of the session rather than, strictly speaking, a user. Now, certainly when Joe or Jane user uses their own Oracle account to connect to the database, that is a session that happens to correspond to an Oracle user. That's true. But it doesn't have to be that way. It could be a module within your application. It could be a specific subroutine within a code module. You see? Look at all these options we have for tying your application code and SQL code into a consumer group. Think of processes. We have client program. We can map to operating system users. We can map to host names, client IDs. The idea here is that we can create consumer groups that map to whoever or whatever is logging into Oracle, be it a module within our line of business application. It could be an Oracle subprocess. It could be a user. As I said, it could be a machine. Now let's finally do that demo I keep referencing so you can see what this stuff looks like. Welcome to our demo on Oracle Database Resource Manager. We're going to start this nugget in SQL Developer, then we'll go into Oracle Enterprise Manager, and then finally return to SQL Developer because I want to show you Resource Manager components both from Database Control GUI interface as well as by using the PLSQL package itself. You might be asked questions that require you to know a bit about the API here. Now, as you'll see in my sample file here, I wanted to start you off by just showing you how simple it is to initiate a plan on your system. Alter system set, the initialization parameter, the one and only one for instituting a plan, is Resource Manager Plan, and you just specify the name of your plan. This could be either a built-in plan like default plan, or it could be one that you've created yourself. And then there's also a parameter for SID. That's all there is to it as far as turning on or activating a plan on your system. Now the question, this is probably question and answer 1. Question and answer 0 would be, is Resource Manager enabled on my system? Oracle's received some flack from the user community in recent versions of Oracle Database in terms of whether your default installation has Resource Manager turned on or turned off. Some DBAs hit the roof, for instance, when they upgraded to 11G R1 and realized, wait a minute now, what's going on here? Why is my CPU automatically being throttled? Well, as it turned out, Resource Manager was turned on those systems by default. We can get an answer to that question on any Oracle 11G system by running a query against the $RSRC_plan dynamic performance view. Let's run that right now. I'm going to connect to sys. If the query returns a row, then that means you do in fact have a plan active. I don't, as you see, so this means that Resource Manager is effectively disabled on this system. Another useful query I just want to give you right at the start answers the question, which consumer group is a particular session in? That's obviously something we want to know once we get a resource plan off the ground. There's doubtless going to be a period of debugging and troubleshooting when you roll one of these out. We can select SID and resource consumer group from $session, and this will give you a list of session IDs as well as their consumer group mapping. Obviously, they're all null in this case because I don't have a plan active at this time. If I come to the top line and initiate a plan, which I just did, we now can rerun the second query and learn that we have the default plan turned on. And finally, if we run this third diagnostic or monitoring query, we now have options. We have session IDs as well as a reference of which built-in groups these users fall into. And essentially, it's going to be other groups, Oracle background group, my connection as sys will be in the sys group, and then as you deploy additional groups and add them to your own resource plans, you'll see your own personalized results to that. Now, if you want to delegate the privilege to administer resource management to another administrator, but you don't want to make the user a system administrator, sysdba, you can run the grant system privilege routine from DBMS Resource Manager privs. In this case, this bit of code is going to grant the Scott built-in user the ability not only to manage Resource Manager, but because the admin option is turned on, Scott can actually delegate Resource Manager privileges to yet other Oracle users. The rest of the code in the sample file goes through a fictional case where we want to create a resource plan that gives a consumer group called reporting group a maximum of 5 active sessions and 5% of the CPU. So this reporting group is going to get heavily throttled from the looks of it. And the code that we'll be using in the sample has been adapted from, of all places, an obscure IBM reference site. This is the shorty URL that'll take you directly to that article by way of citation. Now, I told you I wanted to show you the graphical interface of Resource Manager. That's what we'll do right now. I'm going to log into database control using the sys account with sysdba privilege. We can find Resource Manager on the server tab. It actually has its own group carved out for it, and it's divided into 6 sessions. Getting started, which is a really nice, helpful overview that helps us walk through Resource Manager. It's definitely where I recommend that you get started with this. And then we have specific links to drill into each of those components. Consumer groups, consumer group mappings, also called consumer group memberships, plans, settings, and statistics. We'll go to statistics first. There's not going to be too much. Well, there is some stuff to see now. I just remembered that we do have a plan enabled. And this is going to give us a color-coded histogram that we can customize automatic refresh or manual refresh, as you see here, that shows you those different metrics. CPU consumed, depending upon the group. It looks like our other groups are consuming more CPU than I am as a sysdba. I/O requests, I/Os per second, waits, and then we have queued sessions, reprioritization, idle session data. This is a good screen to go to when you have a resource plan in use and you want to see basically metrics on how it's performing. Who's doing what is a good way to say it. The settings page, as you see here, allows us to choose a resource plan from the drop-down list. I haven't created any on my own, so all of what you're seeing here are built in or in-box with Oracle 11G Enterprise Edition R2. I want to draw your attention here to the default maintenance plan. This is the built-in plan that's meant to customize maintenance plan tasks. You can activate a plan manually from this settings screen just by clicking Activate, or we can click View Selected Resource Plan to go to the View page as you see here. And this is showing, first of all, the metadata in terms of its status, its description, which scheduler window or windows it's associated with. And it looks like this plan is attached to every window each week. So it will automatically kick in depending upon your window time frame. As I said, we'll revisit windows in the next nugget. The guts of it is down here under Resource Allocations and Directive Values. The resource allocation deals with the CPU utilization, and it looks like the first priority, or the level 1 priority, gives the sys users 75% of the CPU. Remember, this is just a minimum guarantee when the CPU is pegged on the system. Unless a session or the server is starved for CPU, there will be no need for the plan to step in. But if the plan does need to step in and actually exert some of this muscle, sys users are guaranteed 75% of the CPU. Now, the remaining 25% cascades down to level 2, as well as any overflow. If the sys group is only using 25% of the CPU, then that gives an additional 50 plus the 25 that's left over to cascade to level 2. You see how that works? And in that schema, it looks like the auto task sub plan, which is a plan on its own, has 25% guaranteed CPU, and the diagnostics, whatever that is, I would guess that that's a consumer group, gets 5%. Now, we would have to step back a window to look at the components of the auto task sub plan, but I would reckon that your maintenance tasks are associated as consumer groups within that sub plan. The rest of this deals with other metrics: execution time limits, I/O time limits, as we said earlier, maximum undo space, execution times, and you'll see that this default plan doesn't mess with any of that. All of those are set to their default values. It looks like this default maintenance plan, all it does, and actually we can read this from the description, it's set for maintenance windows that prioritizes sys operations, allocates the remaining 5% to diagnostic, 25% to automated maintenance operations. So we can rest assured that no more than 25% of the system CPU is going to be chewed up by maintenance. Now, you may want to devote more processing power to the auto task subplan here. You can easily do that, as I said, by editing a maintenance plan. And as you've come to expect, Oracle Enterprise Manager is kind of a loony labyrinth in terms of there's like 3 or 4 different pathways to get to each screen. I'm just going one of many. But as you see here in the Actions area, we can click Edit, and this allows us to customize exactly what's going on with regard to those allocations. For instance, we know that this is going to add up to 100, right? We might want to boost the auto task up to 50%, and maybe we'll make other groups 45 and Aura Diagnostics 5. We can do that if we want to. If we click Show SQL, this shows us exactly what's going on, and it's giving us a pretty honkin' large SQL block. The reason I'm showing you this, friends, is to see that under the hood, what's going on is that Oracle is calling the DBMS Resource Manager package. This is the big daddy package, so to speak, that covers the Resource Manager. Basically, the vast majority of your operations with Resource Manager come through subroutines of the DBMS Resource Manager PLSQL package. Now, you'll notice these calls to something called the pending area. This is one of the weird aspects of Resource Manager. Consider that a scratch space. If you're going to create your plans from scratch, I guess pun intended, using PLSQL, the first thing you always want to do is clear out an existing pending area that might be there with clear pending area, and then create a fresh one. That's just, like I said, one of those things. You have to have a pending area, an in-memory scratch space available to do your plan. Then you do your plan itself, and this shows really just the directives of each plan. Basically what you saw in the GUI, this is just showing you the details with PLSQL. But once you've finished your plan, it's a question of submitting the pending area, which takes your scratch space, your in-memory scratch space, and commits it to disk and commits it logically to the data dictionary so it'll stick around. background. And then, of course, there's the question of activating the plan, which I showed you how to do before with alter system set resource manager plan equals the name of the plan. So let's return, make sure that my change is still there. And you see that for resource allocation, you can switch between percentage and advanced. I tend to stick with advanced because it gives us more flexibility. For instance, you might, as a general practice, always want to make sure your first level gives sysgroup priority, and then any leftover CPU goes to additional groups or subplans. Secondarily, remember you always have to have a directive that covers the other groups, that serves as a catch-all. I'm going to apply this change to show you, or basically to prove, that we can change those built-in plans. Now then, let's come back to the main page and come to Getting Started. I showed you some of the settings and statistics. The Getting Started page essentially gives us some verbosity or some language that tries to teach you in a really encapsulated way what I've been teaching you myself over the last half hour or so. It gives you handy-dandy links to each building block. The consumer groups, the consumer group mappings, the plans, and then we've already done the settings and the statistics. If we go into consumer groups, that's going to give us a run of all of the built-in default consumer groups. They've got really wacky names. Some of them are fairly easy to understand. For instance, auto task consumer group, I guess we can assume is a consumer group that deals with or is mapped to maintenance processes. Let's see, what else is there? Interactive group for interactive OLTP, ETL. None of these are in use unless they're part of an active current plan. They're just pre-configured on Oracle's part to give us something to work with based on different scenarios. Creating a consumer group is really easy. Let's click Create. I'm just going to call this Test Group. Scheduling policy is run to completion or round robin. I would recommend you leave round robin as the default. And the second option is users permitted to run in this consumer group. And we can click Add and add individual users here. I'm going to manually associate HR, for instance. Click OK. If we come back home and go to Consumer Group Mappings, this determines how Oracle can automatically assign sessions to consumer groups. You saw just a moment ago how to manually attach a user to a consumer group, but it's not always that easy. Sometimes you might have processes, applications, that you want to dynamically associate with a consumer group, such that when that module in action is fired off, it automatically joins a particular group. When a particular client program makes a connection to Oracle, same thing. When a particular client machine connects, and so forth. So the idea here is we can select a connection type, for instance, client machine, and then choose Add Rule for selected type. In this case, the screen is giving us a run of available client machines. In this case, it's just the local server or a nugget, and then we take that machine and apply it to a specific consumer group, for instance, test group. So what this is saying is any incoming connections from OraNugget are going to automatically be mapped to the test group consumer group. On row 6, I didn't do this. This is a default mapping that says if Oracle user sys or system connects, they're automatically dumped into sys group. You see how that works? So you'll want to spend time here on the consumer group mappings and make sure that you have whatever session types going on in your organization that you need mapped correctly. In fact, I don't want OraNugget, which is my server, to be associated with test group. So you notice that when you create a mapping, you can remove it by clicking this little pencil and paper. It goes away almost immediately. If we go to the plans page, this shows us again our default plans. We've kind of been there and done that earlier when we looked at the default maintenance plan. This time let's go to default plan, and which is actually active on the system right now. And this default plan again doesn't seem to touch anything else other than CPU. It looks like the sys group gets 75% of CPU guaranteed out of the box. Any left over, it looks like, is heavily favored toward other groups, which is your catch-all bucket, basically any other session. But it looks like we are guaranteeing 5% CPU for our maintenance tasks. And that may be just ducky for you. Maybe you don't care about automatic tasks, so you could cut that down or bring it to 0. It's completely up to you on how you want that to work. Now, in terms of creating your own plan from scratch, let's come back to SQL Developer. And you'll see here our goal is to create a plan such that a particular consumer group has 5 active sessions and only 5% CPU. First thing we want to do is create our pending area. So in this block, I'm going to call DBMS Resource Manager. We're going to clear out any pending area that may be active right now and create one from scratch. Next, in this example, we'll create some test users that we can and will associate with our consumer group. I'm just creating simple users called Report 1, Report 2, and Report 3. To create the consumer group using PLSQL, what we do there is call DBMS Resource Manager create consumer group, and the parameters are the name of the group, which is going to be called reporting group, and you can add an optional comment. I would recommend using comments wherever possible. They show up in the graphical user interface as you see, and for something as potentially complex as resource plans, documentation is especially helpful. Alright, so there's our consumer group. We haven't created any mappings for it yet. We haven't populated it with any sessions, but the actual plan itself will create the plan called Daytime, and this is going to govern resource management for reporting group applications, and then we use Resource Manager create plan directive to fill out each directive. It's frankly not anywhere near as intuitive as filling out the grid that you saw in Oracle Enterprise Manager. Looks like our level 1 priority is to give the sys group 100% CPU. Now that's pretty generous, I would say, wouldn't you? I mean, it's just going to be whatever is left over. That is, if the sys group is using 70% CPU, then any spillover is going to go over into level 2, which is management P2, priority 2, in which we're specifying the reporting group getting 5% of the CPU. And it looks like we've got a third level priority that we bring in other groups that any CPU left over, that is 100%, is devoted to them. So there is our plan. Relatively simple. Actually, it's extraordinarily simple. We really don't need to get any more complicated than that. We want to make sure you understand how this stuff works. Our next step is to validate the pending area, submit the pending area, and then to be a good Oracle user, or DBA, clear it out for the next DBA's work. Remember that submitting is going to commit our work to the data dictionary. And that's what we want to see down here in the status area. So right now we've created the consumer group, we've created our plan, we've defined our directives. We need to add users or sessions to those consumer groups. So again, we're going to open up another pending area, and we're going to run DBMS Resource Manager set consumer group mapping, and that involves a nested call to the Oracle user routine. There's going to be a different subroutine for each of those mapping types. Oracle user, remember, is just one of them. We'll take report 1, report 2, and report 3, assign those users to the reporting group consumer group. Again, we validate the pending area, submit it, and clear it. So let me highlight that information, and we'll go ahead and run it. Before we quit, we have to put this plan into effect, enable or activate the plan, and we already know the initialization parameter in use for that. So now we can scroll all the way up to the top, verify just with our own eyes that we have that resource plan in use, and we can always check which sessions are part of which consumer group by using this second query. Managing resources review. In this nugget, we tackled really a gargantuan subject. There's no question about it. The Oracle Database Resource Manager is quite a beast, but I hope that I described it in such a way that without minimizing its importance or complexity, I've translated to you what the tool is, what we use it for, what its business use cases are, and then, of course, you understand how the various and sundry components or moving parts of Resource Manager work together. The resource plan, the consumer groups, the directives. We understand how this works using the PLSQL API as well as through Oracle Enterprise Manager. We're going to revisit a little bit of this stuff, as I said before, in the next nugget, in which we cover the Oracle Scheduler, maintenance plans, and maintenance windows. I hope that this has been informative for you, and I'd like to thank you for viewing.